morning, good evening, and good afternoon, every student. I'm teacher Shane from Kangaroo Study. Today, let's see a question about equal height model. Here's the question. As shown in the figure, triangle ABC with area 36 and AD equals to DE equals to EC. With this information, we can know the ratio between three of them, that equals to 1 to 1 to 1, where F is the midpoint of BC and G is the midpoint of FC. We can know that the ratio between BF and FC equals to 1 to 1, and the ratio between FG and GC is also 1 to 1. We want to find the sum of the areas of the shady regions, and here we are adding up the yellow part, green part, and pink part all together. In this question, we know about the area, we also know about the ratio. How do we do this question then? Before we get to the solution, let's look at this example. What is the relationship between area of triangle ABD and triangle ADC when line BD and line DC are equal? Now, with knowing that the line BD and line DC are equal, what is their ratio? Their ratio must be 1 to 1. Let's write down on the graph here. So, in this graph, we can find out that the base of the two triangles are actually equal because their ratio are 1 to 1. Now we know that their base are equal. Let's look at their height here. Their height are also equal. So with knowing that the height and base are equal, and the formula of the area of triangle equals to base times height times half, and the base and height are equal, what is the relationship between area of triangle ABD and triangle ADC? They are actually the same. So here we can make a small conclusion that if we have triangles that have equal base and equal height, they will have the same area. After we finish this example, let's look at another one here. What is the ratio between area of triangle ABD and triangle ADC, where ratio of line BD and line DC are 2 to 3? We write down the ratio first, and we can do the same thing as we did at the last example here. Let's cut these triangles into smaller triangles that are having the equal base and equal height. Now with the equal base and equal height, how do we cut the triangle? We can cut it like this. In this graph, with each small triangles, they have the equal base. Now let's look at their height. Their height are also equal. And with the conclusion we just made, equal base and equal height means the same area. So each small triangles have the same area. Now let's look at the triangle ABD here. With triangle ABD, how many small triangles it include? It includes 2 triangles. Now let's write that. Now with triangle ADC, how many small triangles it include? It includes 3 small triangles. Let's write it down here. Now with this information, can we know the ratio between area of triangle ABD and triangle ADC? Yes, we can know that the ratio between the area of triangle ABD and triangle ADC equals to 2 to 3. Do we see any other 2 to 3 here? We can see that the ratio of line BD and line DC are also 2 to 3. So with this observation, we can see that the ratio between the base and the ratio between area of triangle ABD and triangle ADC are actually the same because they're having the equal height. Here's the problem. What characteristics make 2 triangles have the equal height here? Let's observe here. They cut from the vertex A. So if we want to make 2 triangles having the equal height, we have to cut from vertex. In this example, we come from vertex A, but we can also cut from vertex B. We can also come from vertex C here. Let's see the case that if we don't cut from the vertex, if we cut it from here, one of the shape is not even triangle. And let's look at the height here. The height are actually not equal here. So with these two examples, we can learn that if we have equal height, the area ratio is equal to base ratio. And that's what we call the equal height model. And what makes the equal height in two triangles or multiple triangles? Cut from the vertex, the triangles will have equal height because we draw the height from the vertex to the base. We know about the equal height model now. Let's see how to try to apply it. Let's look at this example. If BD to DC have the ratio 3:2 and the area of triangle ABD is 15 square centimeters, what is the area of triangle ADC in square centimeters? With this question, we know about the ratio and the area. How do we do this question then? Let's try to use the equal height model. With knowing that the ratio of base that is equals to 3:2, then what is the area between triangle ABD and triangle ADC? It will also be 3:2. And with knowing that the area of triangle ABD equals to 15 square centimeters, let's take it as 3 units. With this information, we can know that each unit have 5 square centimeters. And how do we calculate the area of triangle ADC? We just take 2 units, so we can use 5 times 2 to get the area of triangle ADC that equals to 10 square centimeters. So this is how we apply the equal height model. Let's look back to the question we have here. With this question, we also have the area and the ratio. How do we do this question then? We can also use the equal height model. Now with this equal height model, before we apply it, let's look at the ratio we have here. We can have the ratio between the lines like this. Here's the problem. How to build the equal height model? We know that we have to cut from vertex. Which vertex should we cut from? At this time, we know that the area of the triangle ABC. So we should cut from the vertex B here. After cutting it like this, we draw the height. And we also know the ratio between the AD, DE, and EC. We can have the ratio between the AD to DC equals to 1:2. And based on the equal height model, we can know the ratio between the area of ABD and area of BDC. It will also equals to 1:2. Now with this information and the area of the triangle ABC equals to 36, let's take it as 3 units. Then what is the area of triangle ABD? Equals to 36 divided by 3 equals to 12 here. Now we know the area of triangle ABD. Let's just forget about it. Let's look at the area of triangle BDC. What is its area? It is 12 times 2 equals to 24 here. With knowing that the area of triangle DBC and the ratio between the BF and FC equals to 1:1. Then what do we do next here? We can draw the equal height model again here. Now with this equal height model, which vertex should we cut from? We should cut from the vertex D. We can cut the triangle like this. Now with knowing that the BF to FC equals to 1:1, based on the equal height model, we can know the ratio between the area BDF and area of BDFC. What is the ratio? It also equals to 1:1 here. And with knowing that the area of triangle DBC equals to 24, what is the area of triangle DFC? It will be 24 divided by 2 equals to 12 here. Now with knowing that the area of triangle DFC equals to 12 and the ratio between DE and EC equals to 1:1, then what can we do next here? We can build the equal height model again. Now let's build the equal height model. Which vertex should we cut from here? We should cut from the vertex F. After cut from the vertex F, we can divide it into 2 triangles. That is the triangle DFE and triangle EFC. Then, based on the equal height model, we know the ratio between the base, so we can know the ratio between the area of triangle DEF and the triangle FEC. And the ratio must also be 1 to 1. Then what is the area of triangle DEF? It will be 12 divided by 2 equals to 60. Now we know the area of triangle DEF. Let's just forget about it. Let's look at the area of FEC. What is the area of triangle FEC? It will also be 60. Now we know the area of triangle EFC. And we know the ratio between the line FG and line GC equals to 1 to 1. Then what do we do next here? We can build the equal height model again and again and again. Then at this time, which vertex should we cut from? We should cut from the vertex E. Then we knowing that the area of triangle EFC equals to 12 here. And based on the equal height model, we can know the ratio between the area of EFG and area of EGC that will also be 1 to 1. Then what is the area of triangle EGC here? It will be 6 divided by 2 equals to 3. Now, with knowing that all the area of the shaded regions, the sum of the shaded regions area, we just add 12, 6, and 3 together, we can have the answer that is 21. So in this question, that is how you do the question. We use the equal height model, we draw again and again, and we get the area of each shaded regions, and we add them together. Now after we finish the question, let's just do a little summary here. Now for the summary, for the first key point, what is the most important thing we learned about today? It's the equal height model. And in the equal height model, we can know that if we have triangles that have the equal height, the area ratio is equal to the base ratio. And how do we make the triangles having the equal height? If we cut from the vertex, the two triangles will have equal height. So this is the two key points you must learn from the question we did today. After this, you can just do a little bit practice question here. With here, you can know that the practice makes perfection. And if you want to join Gainer Study, scan this QR code and I will see you in the classroom. Bye bye.